6 balls numbered 1, 2, 2, 3, 3, 3 are placed in the bag. Balls are taken one at a time from the bag at random and the number noted. Throughout the question, a ball is always replaced before the next ball is taken. A. A single ball is taken from the bag. Let X denote the value shown on the ball. Find expected value over the X. So what is the expected value? Formula is given in the data booklet, and it's the sum for all possible values of X. Here it's what? 1, 2, and 3, and multiplied by the corresponding probability. So it will be the first possible value of the random variable X, it's 1, and multiplied by the probability to get 1. It's it will be always with replacement, so constant. There will be constant probability to get 1 or 2 or 3 at any trial. So probability to get 1, it's what? Just 1 over 6. And plus the next possible value of X, it's 2, multiplied by the probability to get 2, it's 2 over 6, or 1/3, plus 3 multiplied by 3 over 6. Common denominator is 6, so 1 plus 4 plus 9 is what? 14 over 6, or 7 over 3. The next, 3 balls are taken from the bag. Find the probability that the total of the 3 numbers is 5. Let's consider possible outcomes to get the sum to be equal to 5 for 3 balls. And what are possible combinations? It may be what? 1, 2, 2, and if you consider 1, 1, 1, 3, 1, 1, 2, 4. So the first possible combination is 1, 2, and 2. And what else? 1, 1, and 3. And that's all. But you also may get 2, 2, and 1, or 2, 1, and 2. These are different outcomes. Order does matter here, or you may choose 1, 3, 1, 3, 1, 1. But since it's always with replacement, there will be the same probability to get 1 here, 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 or here and here. So it will be just probability to get 1, probability to get 2, probability to get 2, and just multiplied by 3. Or it's the same as probability to get 1, 2, and 2, plus probability to get 2, probability to get 2, and 1, and so on. And it's one event, and it's like AND, so it's multiplication. Plus, because it's OR, we consider different variance, plus also there will be 3, because probabilities to get this and this will be equal, just equal. So probability to get 1, probability to get 1, and probability to get 3. So it's probability, the total is 5. And it is equal to 3 multiplied by probability to get 1, it's 1 over 6. Probability to get 2, it's what? 2 over 6, so 1/3, and 1/3, plus 3 multiplied by probability to get 1, 1/3, by 1 over 6, 1 over 6, and a half. Probability to get 3 is 3 over 6, or a half. And it is equal to 7 over 72. You may use just a calculator. The next, Again, 3 balls are taken and the median of the 3 numbers is 1. What is median? Median is the value in the middle, and all numbers must be in increasing order. So it may be what? 1, 1, 1, 1, 1, 2, 1, 1, 3. But don't get confused. You need just a group of such balls, but you may get them, you may choose them at either order. You may you may take it as 2, 1, 1 or 1, 2, 1. It doesn't matter. 1, 1, 2. It doesn't matter. You need just finally to have 3 balls with such numbers, so that median of such numbers will be 1. You don't need to get these numbers to be in such order directly. It's not required. You need just 3 balls finally with numbers 1, 1, 2, and so here also you may get 1, 1, 3 or 1, 3, 1 or 3, 1, 1. There are no permutations because all values are the same, so it will be just 1, 1, 1. And again, here all probabilities will be the same, so we can write that probability median to be 1 is just probability of 1 multiplied by probability of 1 plus 3 probability of 1 multiplied by probability of 2 plus 3 probability of 1 probability of 3. And it is equal to probability of 1, it's what? 1 over 6 cubed plus 3, 1 over 6, 1 over 6, 2 over 6, so 1/3. Plus 3, 1/3, 1 over 6, 1 over 6, and a half. And it should be 2 over 27 finally. The next. 10 balls are taken from the back. Find the probability that less than 4 of the balls are numbered true. You should understand that such information indicates what? That it's binomial. And it's not necessary to write here, but let x be a random variable, a number of balls with number 2 taken from the back. And since it's always with replacement, there will be constant probability to get a ball with number 2, and hence x is distributed binomially with parameters np, and is 10 number of trials, it's constant number of trials, and constant probability, it's what? 2 over 6 or 1/3. And we need what? Less than 4 or less or equal than 3. And we need just calculate it, and we use what? Since less or equal, it's binomial. It's binomial CDF. So we choose distributions, and we need binomial CDF because PDF it's for some one value of x and less or equal. We use binomial CDF. And trials 10, probability 1/3, x is 3, less or equal than 3, and we get the answer. It's 0.559. The next. Find the least number of balls that must be taken from the back for the probability of taking out at least one ball numbered 2 be greater than 0.95. So it also lets y be a random variable, number of balls with number 2 taken from the bag, but now y will be distributed also binomially, but now number of trials is unknown, is n, and probability also is 1/3. And probability of what? Probability at least 1 be greater. At least 1. What does it mean, at least 1? It's 1 or greater, so greater equals than 1 is greater than 0.95. And usually it's useful greater equals than 1 to rewrite as probability 1 minus probability of unwanted events. And unwanted, it's what? Probability to get y is just 0, and it must be greater than 0.95. So probability y is 0 is what? It's to the right. Now you can see it will be less, or if you move 1 to the right, you will then what? Divide by minus, and you remember, if you divide by minus or multiply by minus, you should flip a sign, inequality sign, and it will be less than 0.05. But what is probability y is 0? Y is balls with number 2, so you should get 0 balls with number 2, or it means all n balls must be with number not 2. And the probability to get ball with number 2 is 1/3, so all probability to get a ball with a number not 2, it will be what? 2/3. 2/3. And all balls are the same, so there are no permutations. All balls are the same. They it means the same in meaning that they all are with a number another than 2. And such probability will be just what? 2/3 to the power of n, and it must be less than 0.05. Strictly 0.95, yes, be greater than. It's a particular situation of the binomial formula. It's actually a formula according which calculator does calculation for binomial. But you can deduce it without the formula. It seems that it's not suggested to know this formula according to the new syllabus. But if it would be not 0 but 1 ball numbered 2, so it may be what? A ball numbered 2 with probability 1/3, and all other balls will be what? With number not 2. And it will be what? 1/3 to the power of 1 and 2/3 to the power of n minus 1. But this 1/3 may be at either position, at any of n positions, so it will be multiplied by n because there are n combinations. So if question be at least 2 or something like that, you also can deduce this when only one ball numbered 2 out of n. But general formula is like this: probability that y is r is combinations r out of n. Probability of wanted event, it's 1/3 to the power of r and 2/3 to the power of n minus r. And you can see that if one ball numbered 2, so you can see combinations 1 out of n, it's just n, 1/3 to the power of 1, 2/3 to the power of n minus 1. So when it solves this inequality, you may use a graph or what? or table, or consider function and consider table, I can solve just using ln. It's not necessary, it may be harder for you to use ln. You may use table or a graph, but I use ln. So if we do ln, it goes in front, so it becomes n ln of 2/3 minus ln of 0.05. But ln of 2/3 it's negative. It's negative. So if we divide both sides by ln of 2/3, we should flip this inequality sign. So it becomes ln of 0.05 divided by the answer, and you can see that n is greater, strictly greater than what? 7 point something, 7.4. So the least possible value of an integer is 8. The next, another bag also contains balls numbered 1, 2, or 3. 8 balls are to be taken from this bag at random. It is calculated that the expected number of balls numbered 1 is 4.8 and the variance of the balls numbered 2 is 1.5. Find the least possible number of balls numbered 3 in this bag. So expected number or expected value of balls numbered 1, it's again, it will be also binomial with parameters 8 and probability to get 1, again 1/3, and expected value for binomial formula is given in a data booklet. It will be just n and p. Notice that for the first question it will be expected value in general for every possible number to be obtained here, but here it's exactly expected number of balls numbered 1, so it's just np, and n is 8, probability 1/3. No, sorry, it's new situation, so probability is it's unknown, and let it be probability p1, and it is given that it's 4.8. It's new situation, and there is another number of balls, so probability is unknown, but we know that expected value to get the ball with number 1 it's np, and is 8, so this is enough information. Variance, what is variance? Variance is np 1 minus p, again for binomial, and probability to get to it's also unknown, but it's variance, but it's 1.5, so we get another equation. 8 multiplied by p2, 1 minus p2 is 1.5, when where p2 is the probability to get a ball, to choose a ball or to take a ball numbered 2. And we need the least number of balls numbered 3, and we need some equation to find probabilities. Probabilities give a ratio, and if you know ratio, you can finally get ratio in number of balls. So let's simplify it. So P2, 1 minus P2 is what? 3 over 2 over 8 is 3 over 16. And we can see that we can find P1 from this equation and P2 from this equation. So P1 becomes what? 4.8 divided by 8, it's what? 0.6. And it's quadratic, so P2 minus P2 squared minus 3 over 16 is 0. P2 squared minus P2 plus 3 over 16 is 0, and let's multiply by 16 is 0. Or actually, let it be 3 over 16 plus minus plus is 0. So discriminant, you may use a calculator to find roots. Discriminant b squared minus 4ac, and it's 1 minus 3 over 4, it's 1 over 4, and the root of discriminant is a half. So P2, it may be what? Minus b, 1 minus root d over 2a, and it's what? It's 1 over 4, or P2, it's 1 plus 1 over 2 over 2, it's what? 3 over 4, or 0.75. But total probability is 1, and if even we assume that there are no balls numbered 3, we have already that P1 is 0.6, and it cannot be 0.75 because it will be greater than 1. It's impossible, even there are no balls with number 3. So P2 is 1 over 4, or 0.25, and hence P3 is probability to get a ball with number 3 becomes what? 1 minus 0.6 minus 0.25 is what? 0.15. Hence ratio in probabilities is what? 0.6 to 0.25 to 0.15. But all these probabilities arise from what? From a ratio in number of balls numbered 1, 2, or 3. So we need just find this ratio to be in the least integers, and hence we get the least possible number of balls numbered 1, 2, 3, or something like that. So let's multiply it by what? By 100. So it's 60, 25, 15, and we can see that we can divide by 5, 12, 5, 3. So we can see that it's the ratio in what? Least integers, which gives us corresponding probability. So the least possible number of balls numbered 3 is 3, and hence the least number of balls numbered 1 is what? 12, number 2 is 5. Or it may be any multiple of this ratio in the back to give the required probabilities. And that's all for this question.